Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Welcome to chapter 2.2, polar form of complex number and also De Moivre's theorem. So in this topic, we'll learn how to plot complex number in complex plane. So let's see, first of all, your complex plane. So the usual plane that we use in rectangular coordinate is plane of x and y. However, now we have complex plane of x and also yi. So x stands for the real axis and yi here stands for imaginary axis. So let's say we have a point here of AB. So how do we plot here? So A is the length of the horizontal part here, while your B is the vertical part. So this is your magnitude modulus Z. Okay, and you have an angle here, the positive angle. So you can write the standard form of complex number in terms of z equal to a plus bi, where a is your real part and your bi here, this is your imaginary part. So first of all, let's look how to find the modulus of z. Okay, we call this as argument. The argument of z you can calculate by using Pythagorean theorem, square root of a squared plus b squared. Okay, because you can see that this is a right angle triangle. Next, how to find your theta? This is using arctangent b over a. So I really suggest you to use the modulus sign here, because now your theta here should act as your reference angle. Your true angle will depend on which quadrant you are residing. And then let's see your standard form here. Z is equal to a plus bi. We can rewrite it in polar form. So how to get polar form? We need a bit of help from cos theta and also from sine theta. Now let's see from here, your cos theta is equal to adjacent, which is your A, over hypotenuse, which is your R. Therefore, you can write A as R cos theta. Now let's see for your sine. Your sine is opposite, which is B over hypotenuse R. So sine theta is B over R. Therefore, let's rewrite your B. B is R sine theta. Now let's rewrite your A and also your B. Put in your standard form. So A is R cos theta, your B is R sine theta I. Factorize out R. Therefore, this is the way on how to write the polar form, which is R in bracket cos theta plus I sine theta. This is how you should write for polar form. So we love polar form because after this, all of the calculation will be using polar form. So now let's focus on converting the polar complex from standard form into polar form. So we already done this. A is R cos theta, B is R sine theta. So after this, if you want to convert from polar form to standard form, just use this formula. Okay, very easy. However, if you want to change it the other way around, you need to find the R. So R, your argument is just using Pythagorean theorem, square root of a squared plus b squared. And for your theta, this is your reference angle. Beware of your quadrant because it will affect what is your answer. In first quadrant, your reference angle is just the same with your true angle. If you are in second quadrant, and this is your reference angle, therefore your true angle is here. Okay, this is just pi minus your reference angle. Now, if you're in third quadrant, this is your reference angle. So your true angle will be pi plus your reference angle. Meanwhile, if you are in the fourth quadrant, so this is your reference angle, therefore your true angle is 2 pi minus your reference angle. And again, this is how to write in polar form. Z is equal to R in bracket cos theta plus I sine theta. Be careful, your R must be positive and theta must be in one cycle.